So hello guys, I'm Gokulnath and I'm from Kalpakam and I'm doing BE in Mechanical Engineering in Coimbatore Institute of Technology. And in today's video, we are going to discuss about dividing head and some of its method, simple indexing, compound indexing, angular indexing and differential indexing. So guys, let's get into the video right now, okay? And so first we can discuss about dividing head. So dividing head is one of the most important attachment for the milling machines, and it is used to divide the circumference of the workpiece into equally spaced divisions when milling gear tooth, squares, hexagon, octagon, etc. And by saying equally spaced divisions, dividing the circumference of a workpiece into equally spaced divisions, it is said that if we take a round workpiece and it is divided into, for example, it is divided into 40 segments, and this is called equally spaced divisions. And it is also used to rotate workpiece at predetermined ratio to table feet rate. And guys, let's see some of its parts. So dividing it parts: index crank, index plate, worm shaft, and a worm single thread is threaded on the worm shaft, and a worm wheel of 40 teeth is meshed on it, and index head spindle is connected to the worm wheel. So guys, let's remember the parts name, and it's going to be helpful in the upcoming slides. So these are some of the methods of indexing: simple indexing, compound indexing, angular indexing, differential indexing. And let's see each topic one by one. First, let's go with simple indexing. So simple indexing: the workpiece positioned by means of crank, index plate, sector arms. Work engaged to crank must be engaged with worm wheel on dividing head spindle. Yeah, here the worm wheel has to be meshed with the worm thread, and the worm wheel has contained 40 teeth as I mentioned before, and one complete turn on index crank cause spindle and work to rotate 1/4 of a turn, which means if the crank is rotated to a one full revolution and it's going, and the workpiece going to move for one segment. As I mentioned before, the workpiece is divided equally into 40 segments, and if the crank rotates in one full revolution, and the workpiece is going to move just for one segment, okay, and that ratio is denoted as 40:1, which is mentioned here. And this is a calculation of simple indexing where the number of turns the crank has to be rotated is found here. As the teeth on 40, it is mentioned as 40 and divided by n, which is the number of divisions to be cut. If you need a 8 flute cut, and we can find out the number of rotation the crank has to revolve by 40 by 8, which is 5 rotations, 5 revolutions, and also 5 revolutions. And this is how we can find the indexing of by using simple indexing. And angular indexing: setup for simple indexing may be used. A setup which a copy of simple indexing setup which is a copy of simple indexing can be used, and must calculate indexing with angular distance between the divisions instead of number of divisions. Instead of number of divisions, we are going to use the angular distance between divisions. One complete turn of index crank turns work 1/40 of turn, and 1/40 of 360 is equal to 9 degrees. As I mentioned before, it has got 40 equal divisions, and as it's 40 equal divisions, and whole circle is a 360 degree, and just one of its segment is 9 degree, cause it's 1/40 is one segment of the 360 is 9 degrees. So indexing in degrees can be found out by number of degrees required divided by 9, which is number of degrees required is, if you need 45 degree, we can be found out by 45 divided by 9. And also the indexing in degrees is found in angular indexing. So let's move on to compound indexing. So when it comes to compound indexing, when the number of divisions required is outside the range of simple indexing and the compound is used. Yes, when the number of divisions required is outside the range of simple indexing, then the compound indexing is used. And the turn the crank in definite amount in one direction, as in case of simple indexing. In simple indexing, we are going to only rotate the crank. We are going to only rotate the index crank, not the index plate. But in compound indexing, we are going to rotate both the index plate and as well as the crank plate, and it can be in the same direction as well as in reverse direction too. But if you are rotating in the same direction, it is positive. If both of the plate and the crank rotates in the same direction, it is positive, and if they are rotated in opposite directions, it is said to be negative. So to understand the principle of compound indexing, we can see the following example, which is mentioned here. The crank is turned 3 hole on 18 hole circle, and the index plate turns further 5 holes on 20 hole circle, and we can say that 3 by 18 plus 5 by 20 equal to 5 by 12. And as I mentioned before, here the crank and as well as the plate rotates in the same direction, so we are taking it as positive 1. So let's move on to differential indexing. So in differential indexing, when 40 by n cannot be reduced to a factor of one of the available whole circle, and here indexing plate has to revolve either forward or backward part of the turn, while index crank turn to attain proper spacing. So change the rotation to rotation affected by ideal gears or gears in gear train. Here, let's see the calculation. Number choose close to required division that can be indexed by simple indexing. It can be done by simple indexing, but for example, assume index crank has to be rotated 1 by 9th of the turn, and only 8 holes is whole circle is there. Crank moved 1 by 9th index pin contact plate at spot before first hole. The exact position would be differ between 1 by 8th 1 by 9th revolution of the crank, and we can say this as 1 by 8 by minus 1 by 9 equal to 9 by 72 minus 8 by 72 is equal, and we can therefore conclude that get 1 by 72. So 1/72 of the turn shots of first hole. Since there is no hole at this point, it is necessary to cause plate to rotate backward by means of change gears. 1 second 72nd of the turn of pin will engage in hole, and this is how the differential indexing is done. And guys, I hope you guys understand it well. I have explained about the 4 indexing methods, and thank you for your cooperation, and let's learn together. Thank you.